But in this case, I can enter Doug in because I didn't put in his first name. Now, we go and enter in some students, and because I've defined that as a foreign key, I have faculty number 1 through 4 in there. I can't enter in a faculty number of 99. It gives me an error. I can enter nothing in there, right? Because I made that an optional field. But if I put something in there, it has to be a valid number.
That's the referential.
That's the referential integrity, exactly. Now, a couple other things to demonstrate. I made that a unique index, so I couldn't give Doug the same email as me. All right, it complains about that.
When did it let you delete Paul's name?
I'll show you that in a second. That's sort of a fluke in Access. Before we get to that, I won't be able to delete me because I have students, and I did not set to cascade delete. The reason that I was able to remove Paul's name is first name I have allows 0 length. So there's a difference between a null value and an empty string. All right? That's one of those things that I think if you think about it too hard, your head explodes. But there really is a difference between those two things. A null is like having no value. All right? An empty string is a string that has no characters. There's a subtle difference, but by picking this collection of them, or this combination of them, making it required and allowing 0 length, I can put an empty string in there. I can't put a null in there. All right, that's why I couldn't enter it in initially. So that's kind of goofy, but that's how that works. If I did set it to cascade, by the way, and my apologies to Mary, we'll delete her, but we'll add her back in. If I did set this to cascade delete, then if I deleted me, it's going to delete Mary as well. So Mary's gone now, which again, in this particular case, doesn't make sense. Oops. All right. Okay. Now again, different databases do that differently, but they all have the same characteristics. You can create tables, you can create columns in those tables, you can define keys, you can define indexes, you can define properties for those fields, for each of the columns in the database, and then you can create the foreign key relationships and either cascade or restrict. There's a third option that some databases provide, and that is to null out the field if it's optional. So for example, in our case, if that option was available, if they deleted me, it would blank out the faculty advisor for all students that I advised, which is sort of a nice thing. Now, do remember again, we're talking about on the fundamental database level. We can write our applications to do a lot of different things, right? I could, in past years, I've taken and written it so that if you try to delete a faculty person, and they have students, it shows you a list of students, and then you can reassign those students to other advisors. All right, so you can handle things a lot of different ways on the application level to make your life easier. Even, the fact that to enter in a student now, we have to know the faculty ID. Well, obviously that's not a good idea. We're going to allow the use of drop-downs so that we can easily see the name of the faculty advisor. But again, that's something we can do on an application level. All right, so that's implementing a database. Now, on to SQL statements. And this can be a little confusing. SQL is a language that's used to access data in databases. I'll tell you what, before we do that, let's have a 5-minute exercise. One last database design exercise, and then we'll go on to SQL. Let's say I wanted to allow there to be majors in my database, and I wanted students to have potentially multiple majors. So you could major in a couple different things. Let's think of how we would implement that in the database that we have there. So let's take 5 minutes, we'll do that, and then we'll hop on SQL.
And he said we should compare notes, so that won't be well, they're gonna be working on that, so you might wanna get that map done and then start on admin two. Work on admin two, because they're going to be unplugging computers, which would be good if you were working on that. Yeah, so when you go
to our ERD? How many tables do we add to it? Two. And what are those tables?
Major
Uh-huh.
and student major intersecting.
Exactly. So we would have a faculty table, student table, major table. Based on how I've defined it, I said that a student could have multiple majors. The assumption is that a major can have multiple students associated with it. All right? And therefore that can't stand by itself. We would have to go and make a student major table. What would this table look like? What would be in it?
The student major table.
Mm-hmm.
Foreign key for the students and foreign key for the majors.
Exactly. Foreign key for the student, foreign key for the majors.
Scroll fine tonight.
Well, that's good. I mean, these things do definitely fit a pattern. You know, you implement them all sort of the same way. Now, and that this together would be the primary key, the student ID and the major ID. That would point to that. That would point to that. An alternate way to do it would be you could use a student major ID, which would be an auto number, and have these two as simply attributes and foreign keys.
Doesn't that just store a lot of unnecessary numbers?
What, this approach?
Mm-hmm.
Nah, not really.
I mean, because isn't every single student that's going to have a major going to generate a new number based on that?
Yeah. But, you know, I've said facetiously in the past, you know, it's not like we're going to run out of numbers. All right, so yeah, that isn't really an issue. If you did this, you should probably make this combination a unique index. Because again, a student can't major in the same thing twice. All right. Now, what you could do in this situation, you could do it either way if the combination of those two are to be unique. If the combination isn't going to be unique, like for example, if you had an automobile that could have many oil changes, then you wouldn't want to make the combination of those two the key, because that would only allow you to enter in one oil change per automobile. All right. SQL. Sometimes it's confusing because, again, you know, sometimes when people talk about SQL, they're talking about Microsoft SQL Server or MySQL or whatever. SQL is standard query language, I think. It's the language of databases. And through SQL, we can do queries, which means pull the data out of the database. And we can do manipulation of data. That is adding rows to our table, updating rows, and deleting rows. All of these have a place in our web applications that we're gonna build. Actually, probably the most complex one is the queries. Because with queries, we can take and we can combine the data any way we want to. All right? Virtually limitless, the different ways that we can combine the data in our tables. If you think about it, our process of database design, we took a big pile of data and broke it down into all its entities. All right? What the queries allow us to do are to combine that data back together in virtually unlimited number of ways. Remember, the more different ways that we can combine data, the more useful that data is going to be, and the more information we'll be able to glean from that data. So the query part of SQL is very, very, very flexible. All right? Let's start with a basic query statement and that is the select statement. The select is a basic query statement. In its basic form, its simplest form would look something like this. Select a list of columns from the name of a table. So, in our school example, select student first name, student last name from student. And what's that going to give you? That's going to give you a listing of all the students' first name and last name in a table. Right down the line. All right? That's about the simplest form of a select that we can have, except for one. And that is where we put in the wildcard of an asterisk to select all the columns from the table. And that'll give me a list of all the columns and all the rows of the table. Now, if we don't say which students we want, we're going to get all of them. All right? That's sort of fundamentally true with all SQL statements. If we don't say which ones we want, we get all of them. So, if I don't specify, gee, I only want those students that are in Ohio, or I only want those students that are CISS majors, or I only want those students that have earned more than 18 credit hours. If I don't specify some condition, we get all of them. Now, that has some dangerous implications when we get to the delete and the update statements, right? Because the same rule applies there as well. If we don't specify which one, it'll do all of them, or try to do all of them. And that could potentially be dangerous when you run around to getting a delete statement going on. All right? So, but that's sort of a characteristic of that. All right? And we haven't talked about the part of the SQL statement that allows you to pick which ones. That's known as the where clause. But we're going to save that for a little bit. All right? So, that's the simplest form of this. We can tack on to this an order by clause. And what an order by clause will do is it will put it in a certain sequence. If you don't specify an order by clause, the database will return you those rows essentially however it feels like it. Now in the case of access, typically that's going to be in primary key order. All right? But you can't assume that. You can't assume that because other databases are liable to be implemented differently. If I don't specify the order of these, it's just going to return them however it feels like. So, the way that I can specify an order is by saying order by, and then I can put in how I want it sorted. SL name, SF name. What that would do is that would sequence it by last name and then by first name.
That all be one statement,
Yeah, this is all be one statement.
all on the same line.
Yeah, all in the same line, or you actually can break it up. It depends on what tool you're using to enter your SQL statement. Now, when I specify two sorts, what that means is if there's ties, then it will sort within that group by the secondary sort. So for example, if I sorted by last name and first name, Adams would appear near the top of the list. Within Adams, all right, it would be sorted by first name. So Bill Adams would appear appear before Charlie Adams, it would appear before David Adams, and so on down the line. The default for this is ascending order, which means from lowest to highest. And in the case of text, that's essentially alphabetical order. All right? In the case of numbers, it would be numerical order. In the case of dates, it would be chronological order. You can also sort in descending order. So if I wanted this list to appear with the Z's on top, all right, I could say descending. And then it would put the Z's on the top, then the Y's, then the X's, and so on down the line. And I could mix and match, right? I don't know why I would want to, but I could sort by last name descending, but first name's ascending. And if you leave off the method, it's assumed to be ascending. Now, a few things to recognize here. Avoid calling columns by what are called reserved words in the SQL language, because that'll cause you grief. That could cause you grief. So therefore, don't call a column DESC. DESC is a common one that I will occasionally slip up on, because I'll think, okay, I want to store the description, so I'll call it DESC. Well, depending on how you write it and all that, that could get it confused with descending and cause your statement not to work. Don't call a column select from. Order's another one that people slip up. You know, they might think that this is the order that they placed and call something order. You know, so avoid using reserved words.
Does it let access let you know if you're putting in a reserved word?
Typically, it does. I'm pretty sure it does. I know name is a reserved word, and I know if you try to call a column name, it tells you that. So, pretty sure it does. But again, if you're aware of them, you know, then avoid them. All right, here's what I want to do. All right, I want to take our database that we just built, and I want to write a simple page that accesses the table in it. Using a select statement. And what I want to do is I want to pull up I want to do a list of all the faculty members and display their names in alphabetical order. And display their last name, first name, and email address. I can actually do this in Access to test this out by going into Query Design. And if I go into SQL View, I can actually type in my own query here. What I'm going to do so you can actually stand a fighting chance of reading it is type it into Notepad, then I'll copy it and paste it into Access and run it. So, I want to see the faculty's first name, faculty's last name, email address, from the faculty table, order by faculty last name, faculty first name. All right, again, word select indicates that we're doing a query. Immediately after the select is the columns that we want to see. All right, faculty first name, faculty last name, email address. From faculty indicates the table that we want to pull that from. We're not interested in student information, we're just interested in faculty information. And then lastly, how do we want that sequenced? We want it ordered by first the last name, and if there's any ties with last name within a last name group, we want to sort by first name. So, I can go in here and I can copy it and paste it in there and click run, and it shows me the result set that it came up with. All right.
Where did you paste that to?
Where did I paste that to?
Yeah.
Under queries.
Oh, okay.
Under queries, I went into SQL View. All right. So, I'm reasonably sure that that query works. And sometimes it's good to go and make sure your query is working in Access before you build it into .NET. All right. Simply because, again, you're worried about then one thing at a time. You're getting the query down, and then you're worrying about implementing it in the .NET platform. All right, now let's go and build a page that accesses this. All right, so let's go and create our Visual Basic app. So I'll go here. New website. I will put it on the desktop. Call it student. I'm going to create an empty website. Oh, I switched from website to empty website. I was going to say what I typed in. All right. I'm going to go in here and create a place to put my database. All right. Now, keep in mind, in larger production environments, this database could be a lot of different places. It might not even be on the same server as a web server. But for what we're doing in terms of learning and in development mode, we're going to keep everything together, and we're going to have our database as part of the application. But we're going to put it in a special place. Okay? And I'm going to create a folder. Underneath my application, I'm going to call it app_data. All right? App data is a special folder. All right? What's so special about it? It's special because there's security implications of it. In other words, you don't want people from the outside world to be trying to access your database directly. By putting your database in the app data directory, there's security built in to the .NET platform that will prohibit people from accessing it and potentially maliciously finding stuff about it. All right. So I'm going to take my student database and put it in my app data folder. All right. I can then go up here and hit refresh. And then I can see there it is inside my app data folder. All right. Now I'm going to go build my page. So I'm going to go up here, New, File, Web Form.